feel like you're trying to crack a secret code when you're trying to understand how the technology we use every day actually works? It's like you're bombarded with this wall of jargon and processes that are so complicated. But think of this as your cheat sheet, like your decoder ring. Welcome to the deep dive, where we break down those complicated tech topics and dig out the stuff that really matters.
Yeah, and today we're diving headfirst into something that's kind of the bedrock of making sure all the software you use actually works like it should. I mean, everything from your favorite mobile games to, this intense banking apps. We're going deep on software testing levels.
Right on. You've got some super interesting material here that really shows this whole systematic approach to making sure that software doesn't just, work, but actually works well. Our mission, if you will, today is to explore these distinct testing stages. We really want to uncover why each one is so crucial to making software you can rely on. And this isn't just for the hardcore tech people. Understanding this gives you a whole new appreciation for just how much goes into creating those digital experiences we kind of take for granted, right?
Absolutely. We're going to be navigating through 4 key levels. Think of them as the pillars of this whole software testing process: unit testing, integration testing, system testing, and acceptance testing. They work kind of like a series of checks and balances, each one designed to catch different types of problems, but at different points in the development process.
Okay, so let's jump right in. Let's start with that ground level, unit testing. What's happening at this very granular stage?
So unit testing, it's all about scrutinizing the tiniest parts of the software, the smallest bits of code in isolation. Imagine a really intricate machine, right? Unit testing is like taking each gear, each lever, examining it under a microscope to make sure it works perfectly before you even think about assembling the whole thing. And these units, they're usually individual functions, methods, or just little chunks of code. It's amazing because these unit tests, they're so detailed that they kind of become like a living record. They actually show how each piece of code is supposed to work. And that is invaluable, especially down the road if the original developers move on and new engineers need to figure out the system.
So what's the big goal here? What problems are they trying to fix at this very early stage?
Well, the main thing is to find and eliminate those pesky bugs in the very first stages of development. It's all about catching them early. Think about it. If a tiny piece of code has a flaw, it's so much easier and cheaper to fix it right then and there rather than letting it kind of spread through the whole system and become a bigger issue. And unit tests, they don't just find bugs. They also make absolutely sure that every single function is doing exactly what it's designed to do, confirming that the right input leads to the expected output and that any unusual cases, those edge case scenarios, are handled smoothly, nothing crashes or breaks unexpectedly.
So how do developers actually carry out these unit tests? Can you paint us a picture of what that actually looks like?
Sure. So they'll write these automated test cases. Think of it like a script that feeds specific inputs into that little piece of code, that unit, and automatically checks if the output is what they expected. Sometimes they'll use mock objects. It's kind of like having understudies in a play, right?
Ah.
They can step in for the main actors, the other parts of the system during rehearsals, during the unit tests. This way, they can focus on whether our actor, the code being tested, is delivering their lines perfectly without being held back by whether everyone else is ready. They're also on the lookout for exceptions, like those surprise errors that could crash the function and any logical flaws within the code itself. They have all kinds of tools for this: Junit, Unit, PyTest, Mocha, Jest. They're like frameworks that let them structure and run these tests really efficiently.
Wow, you mentioned all those tools. It sounds like even these little building blocks have their own quality control team. Can you give us a real-world example of unit testing in action?
Definitely. Let's go back to that e-commerce site we were talking about. Remember that simple discount function? Well, unit tests would be super meticulous, making sure that it's applying the right discount percentage based on, say, different order totals. They'd want to make sure that it doesn't accidentally give a discount that makes the price negative, right? And that it can handle special cases like when you get free shipping. Catching a tiny bug here at this early stage prevents potentially huge problems down the line when real customers are trying to buy stuff.
Makes sense. You got to nip it in the bud at the smallest level. So once all those individual pieces are tested and, fingers crossed, working perfectly, what's the next step to make sure they all work together as a team?
That takes us straight to integration testing. Now, instead of looking at those individual components in isolation, we're looking at how they interact with each other, how they talk to each other, how they work together. It's about checking the connections, the communication pathways between all those different parts of the system.
Right. So, like, we've made sure all the individual bricks are perfect. Now we need to see if those bricks can actually form a wall, right? That sounds like where integration testing comes in.
Exactly. It's like an orchestra, right? Each instrument might sound amazing on its own, but you need to make sure they can play together in harmony. And the main goals here with integration testing, they're all about uncovering those problems that pop up when different modules start talking to each other.
What kind of problems are we talking about here?
Well, it could be issues with the interfaces between them, those points where they connect, making sure that data is flowing correctly from one component to the next without getting corrupted or lost, and checking things like API calls. That's basically one part of the software asking another part to do something or provide information. We also test those interactions with databases to be sure data is stored and retrieved correctly across different parts of the system.
So how do they actually make sure all these different pieces are playing nice?
They'll simulate real-world interactions between these integrated components. Sometimes they'll use things called stubs and drivers. Think of a stub as a stand-in for a component that's not quite finished yet, just mimicking how it's supposed to behave. And a driver is like a little piece of code that feeds input to the components they're testing. This lets them test the connections even if the whole system isn't completely built yet. Then they'll really dig into how the data is being exchanged between these systems, making sure it's in the right format, and that nothing gets lost or misinterpreted as it moves around. For this, they use tools like Postman and SoapUI, especially for testing those API interactions. They also use more general testing frameworks like JUnit and TestNG, which can work at this stage too.
You gave that great example of the discount function for unit testing. Can you walk us through a scenario where integration testing would be the hero of the day?
Okay, let's think about that login system again. The part where you type in your username and password, that might be perfectly tested in isolation. That's unit testing, making sure the input fields work and the basic validation happens. But integration testing takes it a step further. It focuses on whether that login part can successfully talk to the database that holds everyone's login info. Does the login system ask the database the right questions? Does it understand the database's answer to either let you in or lock you out? Even if the login screen and the user database both work perfectly on their own, if there's a hiccup in how they communicate, you're still stuck. And that's exactly the kind of problem that integration testing is designed to find. Problems in how the different parts of the software talk to each other and share information.
That makes it crystal clear. So we've gone from checking those individual atoms of code to making sure they can actually form stable molecules, right? What's the next level up in this quest for quality assurance?
That brings us to system testing. This is where we zoom out and look at the entire application as one whole unit, with all those integrated pieces working together as they should.
So, like testing the whole car, after all the parts and systems have been put together, what are we trying to achieve at this point?
It's pretty comprehensive. The goals here are to check that the whole system functions as it should from the user's perspective, to see how it performs under different conditions, and to make sure it's secure. Basically, we're trying to find those issues that only show up when all the modules are running together. And this is also where we start simulating real-world scenarios. We want to see how the system behaves under pressure, under typical usage patterns. It's kind of interesting to think that, when an app I'm using suddenly crashes, it might be because of something they didn't test properly under stress during system testing. That just shows you how important those simulations are.
So how do they go about putting the whole system through its paces? What actually happens during system testing?
They'll do a few different types of testing here. Functional testing checks that all the features of the app are working as they should from the user's point of view. Performance testing, that looks at whether the system can handle the expected load, like lots of users all at the same time. Security testing, that's trying to find any weak points that someone could exploit. And then usability testing checks how easy and intuitive the system is for people to use. They also look at things like whether the system can scale up or down to deal with changing demands. Tools like Selenium are really popular for automating functional tests, mimicking what a user does in a browser. For performance and load testing, they often use JMeter and Load Runner. And then there's QTP, which is now called Unified Functional Testing, or UFT, and it's got a whole bunch of automation features. The main idea is to see if the whole machine, so to speak, runs reliably, efficiently, and securely no matter what you throw at it.
Can you give us a real-world example where system testing would be super important?
Let's think about that online banking app again. So, unit tests would have checked the individual logic of things like transferring money between accounts. Integration tests would have made sure the transfer module talks to the account balance database correctly. But system testing, it takes it to the next level. It would involve a whole end-to-end process, like someone logging in, checking their balance, transferring money to a different account, and then confirming that their balance has updated correctly. They'd also simulate tons of users making transactions all at the same time just to see if the system slows down, freezes, or crashes. And super important, they would try to find security holes, like seeing if someone could get into accounts without permission. It's about testing that whole user journey, making sure the system is strong and secure under conditions that are very close to what it'll experience in the real world.
So we've moved from testing the individual parts to how they interact and now to the entire system as a whole. What's the final stop on our testing tour?
The last level is acceptance testing. And this is where we make sure the software doesn't just work, but it actually meets the specific needs of the business and the people who'll be using it every day.
So this is like the ultimate test. Does it actually do what it was designed to do for the people it was designed for? What are the main things they're trying to figure out here?
That's it. They're making sure it's usable in a real-world situation, that it follows all the rules and regulations that apply, and basically getting everyone confident that the system is ready to go live.
Who's usually involved in this final phase, and what do they actually do?
Often it's user acceptance testing, or UAT for short. This is where they bring in the actual end users, the people who will be using the software day to day, and let them have a go at it, let them try doing their usual tasks. They're basically double checking those core workflows, making sure the software can really support them in their daily work. Sometimes they'll uncover those last little usability issues or tiny bugs that might not have been obvious in those earlier, more technical testing phases. They have tools for managing this whole acceptance testing process too. Jira, TestRail, HP, ALM. They help keep track of feedback and problems that users find and document the outcomes. This stage is all about that real-world check from the people who rely on the software and the stakeholders who decided what they wanted it to do in the first place.
Awesome. Can you give us one last example to really drive home
Yeah.
what acceptance testing is all about?
Let's go back to that mobile banking app. After all the unit integration and system testing is done, they might bring in a group of actual bank customers and give them a pre-release version of the app to try out in a real-life setting. They try logging in, checking their balances, transferring money between their accounts, paying bills, all the things you'd normally do with a banking app. At this point, acceptance testing is all about making sure the app is intuitive and easy for them to use. Does everything work correctly from their perspective as a user? Does the app meet their needs for managing their money? If these users find major problems with usability, or if they find important features aren't working like they should, or if the app just doesn't fit how they actually bank in real life, then it's not ready to be released, no matter how well it performed in those earlier tests. This final stage is the deciding factor. It tells you if the software actually does what it was supposed to do for the people it was made for.
It's really fascinating to see this whole structured approach, right? Going from those tiny pieces of code all the way up to how the actual user experiences it. It makes it so clear why catching problems early is so important.
Oh, absolutely. Finding and fixing a bug during unit testing, it's way more efficient and cost-effective than discovering it during system testing, or even worse, during acceptance testing when they've already built a lot more on top of that flawed code. This whole layered approach, it dramatically reduces risk, it helps create much higher quality software, and in the end, it gives you, the user, a smoother, more reliable, and more satisfying experience.
So let's do a quick review. We've covered unit testing, which checks those individual parts of the code. Integration testing, making sure they communicate correctly. System testing, checking the whole application under different conditions. And finally, acceptance testing, making sure the software meets the real-world needs of its users. And each of these levels, they all play a really important role in ensuring the quality and reliability of the software we all use every day.
Exactly. Each level is like a filter, catching different types of problems at different stages in development. By the time a piece of software gets to you, it's ideally gone through this whole rigorous, comprehensive series of checks at all 4 levels.
Wow, this deep dive has been incredibly eye-opening. Now that we've gotten a better understanding of these different software testing stages, it makes you think about all the work and all the complexity that goes into making even those apps that seem really simple. It's not magic, right? There's this whole structured and rigorous world of testing happening behind the scenes. And it makes you wonder, what does this new knowledge tell you about how those underlying processes contribute to a smoother, more reliable, and more enjoyable experience for you as a user? It's definitely something to think about next time you're using your favorite app.